Hello, hello, testing, testing, testing. Hello, hello, testing, testing, testing. Oh, cool. Oh, there we go, folks. Oh, there we go, folks. It's working on my end, I think. Good morning. I think the snow caught us by surprise. Hopefully you guys are nice and warm at home, just hanging out. So I wanted to start off today by just going over quickly again what's been going on with AP and whatnot with the test. So I was going to pull that up and we would go over that quickly. So hold on one second. So let me also pull up the chat so I can see what you guys are saying. Oh. All right. Cool. Can you guys hear me okay? Is everything working on your end? Say something in the chat. Yes, cool. Very cool. All right, so just quickly going over what's been going on with the AP test itself. I'll throw this window over here. So, it seems like it's going to be a 45-minute exam. It's going to be nothing but free response questions. So from the usual time frame that is, that's probably going to be only 2 FRQs. So eventually we'll get through content stuff. I was thinking about perhaps this week or maybe next week doing some kind of FRQ thing as a group, just going through, hitting some of the major points, looking at the rubric, breaking it down. But it looks like it's going to be just those 2 FRQs. In terms of what exactly they are looking at, if you scroll down, again, I posted this out, but environmental science units 1 through 7 only. So I outlined, I think that's 1 through 13 in terms of chapters, as well as 15, since 15 is the chapter that gets into the heart of Unit 7, which is air pollution. So Units 8 and 9 totally not on there, and that's like global warming and water and land pollution. So we don't need to worry about any of that. In terms of when the test is going to be, you can see that there's an asterisk for 2 different dates. So they haven't said it yet, and they're going to come out with that on April 3rd. So on Friday, April 3rd, you guys will get a chance to see what different test dates. And so far, it seems like they're going to have like an earlier exam date. If you guys want to take it, you feel fresh, you don't want to lose any of that info, as well as a second date just in case you want the extra time to practice. So I'm not exactly sure what the sign up for that is going to look like. I'm not exactly sure how that whole thing will work, but April 3rd we'll find out together. So that's that. On March 25th, today is the 23rd. That means in 2 days they're going to start pushing out some sort of videos for you guys to watch, as well as, I guess, the stuff that I'm doing. So if you click on, I just got to hear from AP Central, if you click on this free live AP review courses, and you scroll down, there's a section that says science. So right here under sciences, if you go to environmental science, you'll see here it says, and the topics can't be right, they said 8 wouldn't be on the test. So I'm not sure if they're changing that or what they're doing with this, but there should be their own live content that should help you guys as well. And it seems like they're doing a 1 to 1:45 time slot. So that's a little bit about the test. Do you guys have any questions or comments about that kind of thing? I mean, they were a little bit vague as to what exactly all this is going to be, but I guess we'll find out more come the 3rd. All right. While I'm live, if you guys have any questions at all, just shoot them in the chat. I've got it open in a second screen so I can see it at any point. I figured what we do today is kind of just go through the PowerPoint. I added a couple new pictures just to hear it from me, even though you guys have the textbook. So today I was hoping to get through kind of what we missed on that first module, along with the second module in Chapter 12. And then I was thinking maybe doing another one of these on Thursday, and then maybe some kind of practice, be that math or some other skill that'll go along with all this. So looks like we've got a couple more people. Also, I just want to throw this out there again. This is incredibly weird for me, so bear with me if this is totally cringe. But anyway, so I think this is basically where we had gotten up to. We got through the AP stuff. Here's Chapter 12, looking at energy generation. One second. Just want to make sure my phone's off. Cool. Anyway, so process of electricity generation. We've been talking about in Chapter 12, right, all the resources, things that give us electricity, and Chapter 12 is looking more at the non-green energy, right? We're looking at coal, we're looking at fossil fuels. All these things are going to make electricity essentially the same way. They're all going to be using a turbine and then sending that through the electrical grid. So all thermal power plants convert the potential energy of a fuel, be that again natural gas, oil, or coal, into electricity. And the turbine is this thing that has blades that can be turned by water, wind, steam, or exhaust gas from combustion that turns a generator in an electricity producing plant. So it's this array of blades that are all going to spin from the force caused by these things being rushed past it. That in turn is going to then turn a generator, and I've got a picture showing exactly how that works at the end. But again, on past FRQs, they've been bringing that up as to like, hey, how exactly does this electricity get created? So kind of understanding the in and outs of each step in this process is important. Then it goes into the grid. I'm sure you've heard of that. Network of interconnected transmission lines that joins power plants together and links them with end users of electricity. So that's the stuff that brings it from the plant to our home, which is usually, lines. So, steps for using coal to produce electricity. The burning fuel from coal transfers energy to water, which becomes steam. So they just essentially boil the water. Kinetic energy contained within the steam is transferred to the blades of a turbine, a large device that resembles a fan, and it has multiple different layers, which we'll see. It looks kind of like a, well, not quite a bee's nest, but it does have an odd shape to it. Again, we'll look at that in a moment. As the energy in the steam turns the turbine, the shaft in the center of the turbine turns the generator, and then that mechanical motion generates electricity. So, if we take a look, just looking at this as a whole picture. So, I don't know if you can see my mouse. I think you can. Yeah, you can. So, you've got the coal coming in, going into this boiler. There is a pipe that brings water in and is going to take that energy from the burning coal, turn it into steam, and then it goes into, again, this thing that is a whole bunch of different fans with blades. You can see that up above. So the steam is thrusting through that, it's going to spin it, and then that is going to spin the generator. And that is what is making electricity. So it always is going steam into turbine, which turns a generator. And then out of the generator comes the electricity, which goes through the lines and makes it to my computer so that I can stream to you. So here is what's going on in the generator, right? You've got this cylindrical coiled wire, and as you spin that, there are magnets on the outside, and spinning wire in these magnets creates electricity. Do you need to know exactly why? No. Perhaps when you get into physics, you'll learn more about that. But here, this is how it works. This is the end step of that turbine spinning, going into this array of magnets and the wire spinning within to create that end product, electricity. There are videos that I have posted in here. I'm not going to play them. You guys can watch them on your own at some point. But you can simply go through, and again, this is posted on my e-board. If it's not, let me know in the chat. But it should help if you want to review this stuff too later. So efficiency. One of the big problems with creating energy in this way is that it's not the most efficient. So there are a few ways that they've tried to deal with making coal more efficient as they burn it. One of these is called a combined cycle. Well, pause. Combined cycle is actually for natural gas. We'll get to that in a second. But combined cycle is a power plant that uses both exhaust gases and steam turbines to generate electricity. We'll see a picture of that. And then these are some words that just go along. These might be in FRQs. They might refer to the capacity or capacity factor of a plant. But to take a look at what it is to have this combined cycle, right? There's two. Combined cycle is the one where you've got the gas turbine being spun by exhaust gases, and then they recover the heat, which then makes another turbine go, a steam one. So this one has two different turbines that are using the fuel from the natural gas along with then the end product, which is heat, which then spins another one. So this is a way of making it more efficient, because instead of just using the heat to make the steam one go, it is using this exhaust gas, the gas being propelled through first, and then after it burns, it's going to make the steam one go. So it's more efficient than simply just burning. Again, there is a video that goes along with this. You could watch that after this. And then this is the other one. Even I get confused sometimes. Cogeneration. So this one is one that we can use to get more out of coal. The use of a fuel to generate electricity and produce heat, also known as combined heat and power. So this is utilizing the heat that is created to heat a building, for example. So it's, instead of you making electricity and then just letting that heat go off and be not useful at all, and then also having a burner to heat your facility, this is co-generating. This is using that heat to also heat the building. So they don't need to have a burner for it. So this can improve the efficiency a lot, because, well, now you don't have this whole extra source that's heating the grounds. So here you've got the fuel coming in. That spins the gas turbine, goes into the generator, you get electricity for the grid and the building. And then with the water, you can recover the heat. You can use that for, hot water, or you can also do it for, not air conditioning, but heating the building. So again, some videos, you can watch those later. So this brings us to all of the different types of fuel and the positives and negatives that go along with them. So this is module 35. So coal is the most abundant and dirtiest of the fossil fuels. Solid fuel formed primarily from the remains of trees, ferns, other plant materials preserved 280 to 360 billion years ago. And there are 4 types. It's like the evolution of going from the most basic, commonly formed coal all the way to the most developed, most dense coal. We'll see a picture of that in a second. The largest coal reserves are in the United States, Russia, China, and India, right? We just saw that huge thing, or a video rather, about how China was getting so much of their energy from coal. It's a huge resource that they have. So here are the different steps. You start out with this peat. Peat is a type of moss, usually in a coastal or boggish area. And over time, it can get buried, right? Ancient forests cover much of the land surface. Vegetation dies, is buried under anaerobic conditions, meaning that it's not getting oxygen, forming peat. Then, after a long time, things build up, it gets buried and buried and buried, and eventually it is compressed into lignite, which is a form of coal, but it is not the most developed. It's not the thing that we are looking for the most. So as time goes on, you get to bituminous coal, and then lastly anthracite. And the more time that goes on, the more pressure that builds up, and the better it's going to be for burning, since it's more energy dense. So that's the formation process. That's how we actually get coal to form. Again, more videos. So what are the advantages? Well, it's definitely energy dense, it's plentiful, and it's around the surface. So it's easily gotten by surface mining, and it's also not something that needs the most technology to get. Yes, you can use giant machines, and there are some other methods to get the more difficult to get coal, but if it is by the surface, all you would need is a pickaxe basically to get it, right? So it's relatively easy, and it doesn't need much or any refining, right? If you get it right from the mountain, you can burn it pretty much. So right, refining is like taking it and getting certain things out, right? So we'll see that with oil. That's definitely a thing that needs to happen. It's inexpensive, and lastly, it's easy to handle and transport, right? You can just pick the stuff up and put it without real containers or anything like that. So what are the disadvantages? Well, definitely it can have sulfur in it, and when you burn it, if you release it into the air, well, that's going to create acid rain, which we don't like. Trace metals like mercury, lead, and arsenic are found in coal as well. Combustion leads to increased air levels or levels of air pollutants, so all those things are going to be in the air, or those things can also be in the ash that's left behind, which could lead to runoff, get into water systems. There's a lot of issues with that. And lastly, carbon is released into the atmosphere, which will eventually lead to CO2, right? That's how it's being released, and that could lead to global warming. So, petroleum is cleaner than coal, right? It is definitely a cleaner burning thing. Fossil fuel that occurs in underground deposits composed of a liquid mixture of hydrocarbons, water, and sulfur. It doesn't have those heavy metals. And we get it as crude oil, which needs to be refined, right? That is the liquid petroleum removed from the ground and then is sent to get refined, where it can turn into gasoline or other products. So how do they get this stuff? Well, you can have certainly different deposits, and each deposit's going to be in a different way in the ground. But in the picture you see right here is where there has been some tectonic energy that has folded these different layers, and you can see that the oil has risen to the top. Think about it like if you see oil in a puddle, right? Oil always wants to go to the top because it's the least dense. So what you do is you just put a well into that, and it is like a straw, and it just sucks it right up, right? It's less dense than the surrounding rock, and there's probably a little bit of pressure there as well. So it just goes right up. And these are the easy deposits to get, the ones that when we were talking about EROI that they've really kind of taxed, and we're pretty much running out of, at least the known ones. So what are the advantages of petroleum? Well, it's convenient to transport and use, especially in cars. Relatively energy dense. This is something that the textbook says, and I actually wanted to look up really quick because I was looking at some of the energy content and densities, and it seems like that's just, I don't know what they mean by relative. If I get this a little bit bigger, you can see here that wood is by the bottom. It's not very energy dense, which makes sense. Followed by, where are we? Anthracite, 31.4, and these are the energy densities in megajoules per kilogram, by the way. And you can see that gasoline is at a 45.8. So I'm not sure what the textbook means by relative. I mean, if you think about it, right, gasoline that goes on fire burns pretty intensely. So it does carry a lot of energy, but I don't really know what they meant by that in the book. So I just wanted to clarify. Going back to other advantages, though. Cleaner burning than coal, for sure. It still has that sulfur, but again, it doesn't have those heavy metals. And then oil is used in many other applications. So, oh right, and I forgot, I put this in as well. Just looking at different energy densities of different things. On the y-axis, you can see that it is being measured by its volume, so the volume of the substance. And then on the bottom, you can see that it's in kilograms, so looking at the weight, like energy per weight and energy per volume. So you can see, again, wood is relatively low, corn's higher than that, coal's pretty good, but gasoline beats it in both, right? So gasoline is higher up on the y-axis, meaning it's more dense in terms of the amount of energy per volume than coal, and it's also going to be better in terms of its weight per energy per weight than coal. So again, I don't know what the textbook was saying there exactly. Maybe I'm reading it wrong, but just wanted to get it out there that there's a lot of energy kicking around in gasoline. So what are the disadvantages of petroleum? Well, it releases carbon dioxide still, right? There's still something coming out of it, though it is only 85% of what you would get from coal. There's a possibility of leaks, which we saw at the beginning with the Exxon Valdez and the BP oil spill in the Gulf, right? Definitely not good things. You don't really get that with coal. Other problems with coal, but you don't get that. Runoff enters marine waterways. This is definitely true. The oil in cars, if that gets on the road, that's going to travel with the rain and make its way into lakes or ponds. And then it does release sulfur, mercury, lead, and arsenic into the atmosphere were burned. More in coal, but sorry, there is some. And we do have unleaded gasoline. We have refined it to different standards, but that's gasoline, right? Petroleum is not just gasoline. It's all petroleum-based products. So different ones will have different amounts of those things. All right, so other disadvantages to get to these new sources of petroleum. They need to go into specific places where, well, we've learned in, what was that, chapter 10, we don't really want people to go in and disrupt. So there's been a lot of issues trying to get petroleum from this ANWR region of the Arctic National Wildlife Refuge, and it's been a dispute going back and forth between preserving the area, but they know that there is a whole bunch of oil there. So I've got some videos you can watch, a couple knowing about the or elaborating on a couple of the things with ANWR. But anyway, going on to the third source, natural gas is the cleanest of the fossil fuels. Natural gas exists as a component of petroleum in the ground as well as in gaseous deposits, separate from petroleum, so it's relative. Natural gas contains 80 to 95% methane, 5 to 20% ethane, propane, and butane. I have seen a question that asked about that from one of the old AP exams, so something to know for sure. The two largest uses of natural gas in the United States are electricity, right, at these plants, and industrial processes, but it is also used, some of you might have stoves at home, right, that you cook, right, tick, 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 and it goes on. That is natural gas coming out of there, right? So we do use it at home. Some people have still oil, but natural gas is used by a lot of housing. So again, some more videos that you can look at. Advantages of natural gas, well, it has much, much less in terms of its impurities, emits almost no sulfur dioxide or particulates. We're not having any like the ash come from this. Emits only 60% as much carbon dioxide as coal, but to get it is a little difficult sometimes. Methane that escapes into the atmosphere is a potent greenhouse gas, huge disadvantage. We don't talk about methane for the greenhouse effect so much because so many more things make CO2. It's just more abundant, so people talk about it a lot. But methane is way more potent. I believe it's like 50 times more potent than carbon dioxide. But again, not many things make methane. I mean, they joke that, like, you know, the cow farts are all methane, leading to global warming. But I mean, it is true, it's just not as prevalent, so people don't think about it as much. And then the other disadvantage was exploration for natural gas can contaminate groundwater. We saw that in like the first chapter, I think, when they talked about fracking, right? You're definitely using a lot of water and chemical slurries to get at this stuff in the the natural gas shale. So it can definitely have some contamination for that area. All right, getting on to the less abundant sources, but things that we have had to go to since all of the easily gotten petroleum has kind of vanished. Oil sands, the slow-flowing viscous deposits of bitumen mixed with sand, water, and clay. Bitumen is a degraded petroleum that forms when petroleum migrates to the surface and is modified by bacteria. It gets kind of like hard, it gets stiff, and I've got a picture to show you in a moment. And then CTL, coal to liquid, is a process of converting solid coal into a liquid fuel. I'll touch on that in a moment as well. So this is oil sands right here. This is that bitumen that is mixed with the sand, the sediments and things. And it is something that is stiff. It's hard. You can pick it up in your hand. And it's not, they say it's slow flowing in the textbook, but really it doesn't flow that much at all. The way that they're going to go and get this stuff is through heat. The only way to really get at this source and like suck it up is to superheat all the bitumen so that it can, I guess, melt down, and then they can suck it up with the things that they would normally do in a well. So this requires, again, a lot of technology, and then they've got to go through and sift out all the stuff that's with that. So all the sediment, all that sand, and all those things that are with it have to be processed out. So it's a lot more work than just getting the regular type of petroleum reserve. So fossil fuels are a finite resource. Energy intensity, the energy use per unit of gross domestic product. Our energy use per capita has been dropping, but with rising population numbers, total energy use continues to rise. Definitely right now, I think a lot of people are using a lot of energy now that we're all home, probably. But per capita energy use has kind of stabilized. Big reason is we're just getting more efficient technology, right? For sure. Our energy intensity, or energy use per dollar of GDP, has been decreasing steadily since 1980. However, because of the increasing U.S. population, total energy use of the nation has roughly been constant between 2000 and 2012. So here is the Hubert curve. This was talking about the oil production, right? When would peak oil production be, and when would we run out of things? So this says, a generalized version of the Hubert curve, whether an upper estimate or a low estimate of total petroleum reserves is used, the date by which petroleum reserves will be depleted does not change substantially. So again, this is talking about how much they think, right? The reserves are like the untapped petroleum, and they thought that it would peak, when did they think it would peak? I think it was the 70s that they were saying. One second. Roughly 60 years from 1969. So, yeah, definitely, it's hard to know. We keep finding new sources, but the point is, at some point, we will start to tap into those resources at a point where it's going to start dwindling. We're going to start running out of it. We're just still finding things. We're still tapping into resources that technology allows us to, right? A while ago, probably was very unreasonable to try and get oil from the middle of the ocean, but now we have these ways of doing that. So the idea here is just, when are we going to hit that peak oil? When are we going to use up, half of our supply? And again, that's going to change with time, but it will happen eventually. So, if current global use continues without significant additional discovery, we may have run out of conventional oil in less than 50 years. Coal supplies will last for at least 200 years, probably much longer. New technology and concern about the release of greenhouse gases is encouraging people to explore alternate energy sources, which is in the next chapter, right? And I think we're slowly phasing in a good amount of those things. There's a lot of solar panels on homes and things like that. But definitely within the next 50 years at a minimum, especially since cars run on all of these, petroleum, or gasoline rather, definitely need to start figuring out what we're doing here. So, nuclear, I'm going to do another day. I'll do that the next time we talk. But if you guys have any questions, I guess this would be a good time to do it. Gross domestic product. Oh, let me go back to that. Gross domestic product I always get these ones confused, but gross domestic product, total value of goods produced and services provided in a country during 1 year. So this is, right, domestic is like at home, right? So it's the value of goods produced in a country. So it is what we are creating. It's what we're manufacturing or providing. So to go back to that, right? Our energy intensity or energy use per dollar of things that are coming out of our country. So that's what it's looking at. It was looking at, right? Trying to think of another way to say that. Right, because every energy use per, so if you look at it in terms of the amount of industry and the amount of people that we have that are using electricity, it's talking about their use or energy use per all of those services. It's a way to quantify the amount of services that we're getting versus the amount of energy that we're using. So if you think of it like that, like a ratio kind of, right? Because it's energy use per dollar of what we're providing. So if that was one second. Let me think of how to put this. So yeah, you're being more efficient if you're using less energy per dollar of what you're servicing, right? And you can see that here, that the graph is dropping, right? That we are getting more efficient, but because there's more people, it's been stagnant, right? So our energy use has been better for every for the services we're getting, but because people tend to be like flatlining with the population growth, there's so many people using stuff that per capita has been the same. Does that make sense? No, the opposite. Right, you want less energy use per dollar of GDP, right? It's energy use, not energy like gained, right? Cool. Any other questions, folks? I'm happy to hang out for a little bit. Also, an alternative to doing YouTube Live would be to do this in Google, where you guys can talk if you don't feel like typing. What did you say was the ratio for it? Well, it says it right here, right? So it's energy use per dollar GDP. So it's not. Their units here, oh, they don't provide units. They're just saying, generally speaking, how much energy to how many dollars. Again, it doesn't say like megajoules or something like that, but they're being kind of general here. What does it say here? Yeah, we talked a little bit about the exam. Just 1 second, looking something up for Sarah. Yeah, I wouldn't worry too much about this ratio. Just the idea that our energy use for the services we've been giving has been going down, but because it says, right, our population has been going up, so total energy has been constant because of that, right? And bigger population using, even though they're using a little bit less, is still going to make it so that it's more of a constant curve. It's not like it's dropping because our population is the same, right? Population's increasing, so it should be generally about the same in terms of the total energy used. That makes sense? Cool. All right. What was your question about the exam? Or just generally anything? Oh, okay. I could go right back onto AP Central. So, just going over this one more time. If you go onto the AP board, you can get to this page. It says learn how we're supporting schools. So just quickly, where does it start saying this stuff? Here you go. So it is only going to be a 45-minute online free response exam at home. It's going to have a shorter amount of content than usual. It's units 1 through 7, which we are in unit 6. Unit 7 is air pollution, which we'll cover probably, I'm thinking like next week. So units 8 through 9, which is global effects, so that's stuff like global warming and invasive species and animal trading, those kinds of things, along with land and water pollution. So those two will not be on the exam. In terms of the dates for when you guys will have those exams, they don't have them up yet. They, are still working on that. So if you go to the bottom over here, information will be posted by Friday, April 3rd. So on April 3rd, we'll all know what the two dates are. This way, if you feel like you want to just like go nuts now and study for like there's going to be an earlier date than usual, if you wanted to get it over with and take it, you can. And then the second date will be the opposite. It'll give you a little bit more time, I think, if you wanted to spend more time looking at things and whatnot. So there will be two dates. I don't know how the sign up will work for that. I don't know exactly how any of this will work, but we're learning together. Lastly, there are going to be free live AP review videos. So if you click the link under instructional support right here, it'll bring you to this page. There's going to be classes that are designed by the AP board. Some teachers, I guess, are going to teach somehow. I don't really know how this will work either. But if you go down to science, you go to environmental science. Here you've got 3 different things. And again, you'll notice that the lesson topics are 8.1, 8.2, 8.3. I don't know why it says that, since we don't have 8 as part of our test anymore. So you're going to want to probably sign in, but it won't be those topics. That makes no sense. So the date is the 25th. That's in 2 days. I'll check it out too, just to see what it looks like. And that's from 1 to 1:45 our time. So, choose the test date? I think you can. I think you choose between the two for sure. But I can figure that out in more detail. Did it say? I might have missed that part. Yeah, I don't know if it said it in here anywhere. Oh yeah, here you go. Some students may want to take the exam sooner rather than later while the content is still fresh. Other students may want more time to practice for each subject. There will be 2 different testing dates, so it seems like it's up to you. The chart in the textbook says that coal has the highest EROEI, but wouldn't that mean it is more efficient? So remember that energy return on investment is the amount of energy that goes into getting it, not necessarily the energy that it contains itself. So like if you look, like, forget about getting the oil, but like if you had the same volume of gasoline and oil next to each other, the petroleum or oil should have more energy in it, whereas with the coal, you're right, that does have a higher efficiency of getting it, right? It takes less energy nowadays to get at that coal than it does to drill at the bottom of the Gulf of Mexico. So yeah, some of these terms are definitely, like, they sound really similar, but they're super, like, just hairs away from each other and what they're trying to get at. Any more questions, guys? Happy to hang out. It's not like I have anywhere to go. I hope you guys are all doing well, by the way. I do miss you. It's certainly weird being home like this. Adios, Daniel. Also, is this useful? I mean, would it be better to have it where you guys can talk and do more of like a review thing, or do you want me to do just like the basics, go over stuff, and then leave it open to questions? Because I'm open to any type of way you guys might want to do this. Okay. Perhaps then when we do more like work stuff, like if I post something maybe on Google Classroom and we work on it together, maybe we could have a Google chat. Oh no, this'll save when I'm done with my broadcast. It'll just automatically save it to the channel. So. Okay. Yeah, especially when we're doing like FRQ stuff. Well, all right. If you guys have any more comments or questions or anything that we didn't get to, I'll leave the YouTube chat open. Well, actually, I wonder if this goes while I'm not broadcasting. Oh, or you could just put it in Google Classroom. I'll be on there, so. Oh, good question. Before we go, how's the rest of the unit going to be planned out with the test? I'm just gonna keep on making videos, trying to reach out and get as much done as we can. We don't have the dates for the test, so it's hard to know exactly when to be prepared by. I would say, like I said on Google Classroom, if you have the time, read ahead, and as we go through stuff, and I'll help as much as I can, we'll do what we can once we know the dates. But that's why I started now. We'll get this stuff kind of closed up, hopefully do some practice, and if we do one of these chapters a week, then we should be good, because I doubt that they're going to have like a April 10th test or something like that. Well, we have the tests at the end of units like we usually do. I honestly have no idea how testing or like school grades are going to work. We haven't really had anything down on paper, and we're still trying to figure that out, I think. So right now, I think you guys should focus on the AP test, since that's the thing we know we're going to be doing. I mean, that's the one thing that they haven't said they're unsure about. So let's focus on that for now. I'm not going to give you graded work just yet. Like I said, if there is something to be graded, the reading guides would be a good place to start, and that should hopefully help you in the test too. So we'll have to play it by ear. I don't think anybody knows how any of this is working right now. Yeah, I know, but if you've read any articles and flattening the curve and all that, it makes sense. It's tough. Yeah, I miss the normalcy of things too. Ooh, yikes. Well, we're here for you, Sarah. Alright folks, well this has been just about an hour-long stream. Again, if you have any other questions or anything like that, just reach out in Google Classroom or email me. Happy to email. I'm home doing, well, not very much. So let's just keep it positive as we can and get ourselves ready for the AP exam. So I'll see you next time, and yeah, I'm thinking Thursday 9 a.m. So hope to see you then.